Our first objective is to distinguish between solutions, suspensions, and colloids. So solutions, when one substance dissolves in another, it forms a solution. So a solute is what gets dissolved or is being dissolving. It's the lesser amount. The solvent does the dissolving. It's the greater amount. Solutions are homogeneous. That means they appear the same throughout. Even though they look the same throughout, they're still mixtures and can be separated by physical change. So Kool-Aid, for example, is made up of Kool-Aid powder and water. So which is the solute, which is the solvent? The Kool-Aid powder is the solute, water is the solvent. Because water is polar, it is really great at dissolving other substances and forming solutions. It's so good at this that it is referred to as the universal solvent. Solutions can be in all three states of matter. So, for example, if you have tea leaves and water, the tea leaves are the solute, water is the solvent, and this would be a solid liquid solution. A gold ring would have gold being the major part, so that would be the solvent, copper the solute, and so both of these are solids, and so they make a solid mixture or a solid solution. A cup of coffee is water's the solvent, caffeine's the solute, and so you have a solid solute dissolved in a liquid solvent, which is a liquid solution. In a fish tank, oxygen would be the solute dissolved in water the solvent, and so oxygen's a gas, water is a liquid, so it's a gas in liquid solution. And then it's the same for a Coca-Cola or Sprite or any carbonated beverage. The carbon dioxide is the solute, the sugar water is the solvent, and that would be a gas in liquid solution. So when salt dissolves, the negative end of the water molecules attach to the positive of the cations and then pull them away from the crystal to dissolve them in the water, while the positive ends of water hook up with the negative anions of the salt and then pull those out into the water to dissolve as well. Once they're pulled away from the crystal, that's when they disappear within the water. Other types of mixtures that may form with water: suspensions, when you have large particles that will mix but will settle out upon standing, temporarily cloudy, but then it separates, like sand and water or muddy water even. Here is where you have the muddy water, and after some time has passed, you can see how all the chunks of the muddy water have settled to the bottom. That is a suspension. Then you have colloids, which are intermediate particles that will mix and not settle out upon standing, usually appear cloudy, like milk in water, or a fog, for example, where everything stays dispersed in the solution. And suspensions and colloids are both considered heterogeneous. Suspensions and colloids both exhibit what's called the Tyndall effect, where when you shine a beam of light through it, the particles scatter the light and you can see the beam within the colloid or suspension, as opposed to you cannot see the beam going through a solution. This is commonly used to tell a solution apart from a colloid. So, particle size: solutions are small, colloid medium, suspensions large. Tyndall effect: the solution no, colloids and suspensions yes. And then can you filter the particles? No in a solution, no in a colloid, yes in a suspension.